Hello students, welcome back. Today we'll start with the topic primary and secondary rainbow. So before starting the topic, let's see what is a rainbow. The rainbow is an example of dispersion of sunlight by water drops in the atmosphere. You know that rainbows are seen after rain. So this is seen due to the water droplets in the atmosphere. This is a phenomenon due to the combined effect of dispersion, refraction, and reflection of a sunlight by spherical water droplets of rain. So remember, it is combined effect of three things: dispersion, refraction, and reflection. The conditions for observing a rainbow are that the sun should be shining in one part of the sky while it is raining in the opposite part of the sky. So you can only observe a rainbow when your back is towards the sun. Means you will observe the rainbow up in the opposite side of the sun. See, here example is given that if the sky is say in the western horizon, right, one part of the sky in the western horizon, when sun is shining in that part, then it must be raining in the opposite part, say the eastern horizon. In order to understand the formation of rainbows, let us consider it diagrammatically. First, let's see about primary rainbow. Okay, you can see this as a water droplet. We are considering this as a spherical water droplet. Now you can see here that a ray of sunlight, when it is incident on the first surface of water droplet, this gray line, we are considering it as a normal. So what will happen? Due to dispersion, it will disperse into seven color light. Right, this first ray you can see red light and last violet light. Okay, the other light colors are between these two. So this is dispersion. Okay, as we know that red color light has less refractive index compared to violet. It is deviated lesser and violet light is deviated maximum compared to other light. Clear? Next, these component rays strike the inner surface of water drop and get internally reflected. You can see here they strike on this inner surface and they get internally reflected. Now this angle, this is the normal, and this angle of incident will be greater than the critical angle. In this case, we can take it as 48 degree. So when that will be higher than critical angle, then it will experience total internal reflection. So you can see here that red light and violet light both are experiencing total internal reflection. Means both are reflected internally. Now this reflected light is refracted again. You can see here at this surface they are refracted again. Now it is found that violet light emerges at an angle of 40 degree related to the red light which emerges at 42 degree. See, you can see here the violet light. Okay, it emerges at an angle of 40 degree with the incident, and a red light that emerges at an angle of 42 degree. This figure explains the formation of primary rainbow. We see that red light from drop 1 and violet light from drop 2 reaches the observer's eye. Okay, the violet light from drop 1 and red light from drop 2 are directed at a level above or below the observer. Thus, the observer sees a rainbow with red light color on the top and violet on the bottom. Thus, you can say that primary rainbow is a result of three-step process, that is refraction, reflection and refraction again. See here, this is the first refraction, second on the internal surface reflection and third refraction. Now, when the light rays undergo two internal reflection inside a raindrop, then instead of primary rainbow, a secondary rainbow is formed. Okay, now let's see in the figure. Remember, in secondary rainbow, the colors are reversed. In primary rainbow, you can see red light at the top and violet light at the bottom. In secondary rainbow, you will see the opposite direction, means violet light at the top and red light at the bottom. Now let's consider the figure for the secondary rainbow. Here you can see that when the ray of light is incident on the outer surface of water droplet, it undergoes refraction. Then it is incident on the internal surface of water. You can see here that at the internal surface it undergoes total internal reflection. Once again it undergoes internal reflection. So due to this second internal reflection, the intensity in the secondary rainbow is lesser compared to the primary rainbow. Now here you can see the angle of the emergent ray for red light is 50 degree and for violet light it is 53 degree. So this is due to, or this is a four-step process. First refraction, then reflection, once again reflection and then refraction. So when there are multiple raindrops, see, this is the observer. He observed from the first raindrop the violet light reaching to his eyes, and from the droplet below, he observes that the red light reaches to his eyes. Okay, so what he will observe? He will observe violet light at the top and red light in the at the bottom. So this is opposite to that of primary rainbow. Remember, the intensity of these lights in the rainbow is lesser in secondary rainbow compared to the primary rainbow. Here you can see the difference between primary and secondary rainbow formation. Okay students, so that's it for today. If you like this video, then please hit the like button and subscribe this channel. Thank you.